In this video, which follows on from the last one with a bit of tidying up, first we've fixed the bug in the loop that I had before, and the bug was that I had the condition for the end of the loop and the incremental point for the loop swapped, and I was also trying to go forward in the loop when I should have gone backwards. So now I've got the correct loop and the correct amount of indentation, and I made a few other changes to my print tree that are cosmetic. They just make the output of the tree look better. And if you see in the command prompt window, this is the kind of tree we now get for this small test program. So you can see it's indented, which clearly shows the layout of the syntax. We've got a program, and inside that statements, and inside that a statement, and inside that an if statement, and then inside that is a condition, and inside the condition is an expression, and the next thing under the if statement is a statement, and then that's an assignment statement, and it's said it's an assignment to C there, and you can see in the expression we've got B, and you can see the little 3-line program that it's parsed underneath there. So the next thing to do is to write a code generator to generate code. Well, that's why we spent so much time on the print tree, because generating code is just to print out some code instead of a tree. So we probably just need a similar template to this print tree. So that's what we can do. We can then add, and this is not a debug, so it goes outside the if-def debug. We could actually make something called write code, or generate code, or print code, or code, or something like that. So it takes in a tree, and then it's going to output some code. Well, I suspect it's going to have the same if t is null, do nothing, and I suspect it's going to be a recursive tree walk, much like that. So instead of print tree, we want to write code of t first, write code of t second, write code of t third. Then the other thing we've got to do is put a declaration and a call for it. So we will need to call write code from the main program here, passing in our parse tree that we previously printed, and we need to add a template for it, which is not if-def debug, it goes in underneath there. So we can write code, and it takes an argument of a ternary tree. So that's our definitions of the main structure of that. One of the hints of how a code generator is structured is we can look at the earlier calculator example that we made, and here it had a routine called evaluate, and what it did was a switch on the node identifier, and I'm going to copy this chunk of code, and did a different thing depending on what kind of node it had. So here we can go to our write code routine and paste in that little thing here. But it's not going to do the things that a calculator did, which is return a value or do a calculation. But it might have this overall structure. And one of the things that we usually that we need to do next is actually design what code we want out, and that's the problem that we've got. So if we don't know what code we want out for what code we've got in, we can't write code to implement it. We've got to design what we're going to do. So we really have to start with our BNF. Or something like that that defines the language. And start to think about what we want to do. So for a program statement, what would we want printed out? Well, maybe we would want something like this. We would need to look for a program, what a main program looks like in C. What does a main program look like in C? We could go and look at our main program. So it goes int main void seems to be what it has. So we could do something like that. So when we got a program, we would want to output int main void open bracket and then something and then a close bracket. That'll be our design for that. So we need to also think, what do we want to output when we get some statements? So if we got some statements, we basically want the code generated for the first statement, and then we want to output a semicolon, and then we want the code generated for the second one. So that's, and we probably want to put a new line in there. Okay. What do we want printed when we get a statement? Well, probably there's nothing much to do there. What do we want if we've got an if? Statement. Well, probably I want to put the C word if, and then I want whatever is in the condition, and then I probably want an open parenthesis, and then I probably want to generate the code for the first statement, and then I probably want a close curly bracket. And we've already removed the with, so then we can think about what do we want to do for the while statement. Well, perhaps that's while some condition do curly bracket and something like that is going to be the C equivalent. It's about the assignment statement. What shall I design for that one? Oh, well, that's going to be simple. It's going to be the identifier and an equal sign and then the expression, not a colon equals. So let's scroll down a little bit. So for the condition I probably generate the same, for the expression I probably generate the same, and so on. So they're all very similar thereafter. So that's my design. I'm going to save that. So that's the first point to make. Without a design, I can't write the program. So now I need to go to my code generator, with my design in mind. So now I know that in the case of a program, I now know what to do. I can printf this string that I've designed here. And then probably a new line. And then in the ... I want to write the code for that main body part, and then I probably want to print the closing curly bracket, and then I'm probably done. So then for the next one, when I'm dealing with some statements, I probably want to write the code for the first part, and then perhaps print a semicolon, a new line, and then write the code for the second part, and then I'm probably done. So for statement, I'm going to let this default action at the bottom deal with it. So for an if statement, I am going to print out the string if space open parenthesis, and then I'm going to write out the code for the first part, which is the condition, and then I'm going to print the closed parenthesis and open curly and perhaps a new line, and then I'm going to write out the code for the second part, which is the statement, and then I'm probably done. So, well, I could just similarly do the while statement. And you can see in my design it's getting very similar. I can printf a while, open parenthesis, and then I can write out the code for the condition, which is first, and then I can probably print the closing parenthesis and the word do and an opening curly bracket and then perhaps a new line, and I can write out the code for the second part, and I can return. So it's the while loop, so I can go an assignment statement. What do I want to do? So for the assignment statement, on the left hand side we've got an identifier, so we want to print that identifier. And so how do we print an identifier? Well, the last time we printed an identifier was in print tree, so we'll put something for that. So let's go and have a look. So if we go back up, how did we print an identifier? It was here. So I could have put that in a method for printing an identifier, or I can just steal it. That's what I'm going to do. So I don't want to print the word identifier, I just want to print the identifier. Otherwise, it's an unknown identifier. So I've printed the identifier, and now I can print the equal sign. And then I want to write code for whatever is on the right hand side, and then I'm probably done. And just for completeness, here if I've got a number value, then I can print that one. And where's the code to print a number value? It's up here. I just printed it like that. Then after I've done that, I can probably just return. And so I've gone through all the various possibilities in my little design, and anything else is caught by the default at the bottom. So it's hard to see all of that in one go. I'll just open up the screen and you can see it's just a section of alternatives of what to print for that piece of code. So we can now try and go through Bison. And check we haven't made any typing mistakes. Now we can build it, but we don't want to set the debug flag anymore. So now we can run it through our test program. So you can see it's now printed out the main, it's printed out the if statement, it's translated the assignment, it hasn't done the condition, because I haven't generated code for the condition. So we have now translated this program into C. I can see one error. I've missed the closing bracket off the if statement. So there we are. I've just fixed that one, and it looks like I've made the same mistake on the while statement here. Got mismatched brackets. So if I now wanted to go a bit further, I shouldn't just read that code on the screen. Once I've run that, I need to put that in test program.c. So I use my compiler to take the input language, our Pascal-Like language, generate C in that file, which I can now stick through the GCC. So I can now get a test program.executable by compiling test program.c. Now it doesn't compile because I've done two things. I haven't got declarations of variables and I haven't finished the thing, but I'm just showing you when yours is complete, don't forget to compile the C code you generated and run it and check it's got the correct result. So we've gone all the way through now from a print tree to a code generator for a Pascal-like language. It should show you how to do all of those steps.